Hello everybody, I am Ben from Team Panic, and today we're going to be talking about my Fleeweight, which you can see in front of me in a lot of different pieces. And more specifically, we're going to be talking about the Fleeweight drive that we have in here, because those of you who saw the last video on the Fleeweight and saw its one and only fight, know that we got mopped the floor with, basically, because this drive is terrible. Now, there is going to be a lot of very, very small things happening in today's episode, so before we get too much further into this, I'm going to bring you guys up to here so you can actually see what I'm talking about. There we go, that's much better. Now you guys can maybe get a bit more of an idea of what's going on inside this tiny little Fleeweight. So this was a drum spinner. There's supposed to be a drum mounted up the front here, mounted on this little brushless motor that I have in my hand. And as you can see in here, we have two very small motors doing the drive for us. Now those are these. They are a little plastic geared 10mm diameter brushed DC motor. And just as a comparison, that is them next to an N20. So an N20 is a 12mm diameter brushless motor, brushed DC motor, and also has this big gearbox on the top of it and a very nice output shaft. Now this is actually the first issue that we face. The output shaft on these is horrible. It's a little cross piece here, but it is so small and so flimsy that when you 3D print something, it's so easy to knock off, it's not funny. That means that combat robots that use these need to have hot glue in the actual crosshatch of that motor, or actually in the crosshatch of the wheel, to keep the wheel on to that motor. Also, I don't know how they've done it, but these things are incredibly slow. They are ridiculously slow. They have somehow managed to pack so much gearing into here that they are just unusably slow, basically. So the whole point of today's video is we're going to take these and throw them away because they are useless. But that leaves us without a drive system for a future Fleeweight. Now, I don't know if I'm going to do the Fleeweight as another drum spinner, but it will basically depend on how this video goes, essentially. We're going to have to try and work out a better way to do this Fleeweight drive, and once we've got a better way to do this Fleeweight drive, then we can start looking at how we attach a weapon and all of that kind of stuff, because drive is going to be key here. So we've got two different potential solutions to this problem, and let's take a look at both of those. So if we move that out of the way, our two potential solutions to this problem are this, which doesn't look like much at the moment, but give me half a second and I'll show you that, and these. So this is something that a lot of you are familiar with. This is a little 9-gram servo over here, and actually we're going to move that over a bit across over here. Now, you also probably know that if you watched my Q&A video, I said never ever to use servos for drive, and I'm going to stick by that claim. But today we're going to do something a little bit different with this. But before we get to the servo, let us talk about this thing for a second. So this here is a tiny little RC car, essentially, that I bought from one of the direct from China sellers for not a lot of money at all. And the thing that I liked about it is that it has an actual gear train with it. So this is the gearing system over here that's kind of like in pieces in a bag. But it has a gear train with a nice output hex on a plastic gear, and it has all of the components. If I get these out of this bag to put all that together. So over this side, if we have a look at this, so you throw this gear down first, and then this gear that way, over top of that, down in there, and that all spins up, and then one of these plates goes on top like that and crunches all that together, and that is actually a nice little gear train in there. And it's something that we could probably pretty easily co-opt into a Fleeweight. The big issue with all of this is that that's the drive motor for this. This here is a pager motor, so this is the type of motor that your phone would use to make the vibrations in your pocket, except for it's got a gear on the output shaft rather than a little metal weight, which is what your phone uses to make a vibration. Now, these things are great. They are a tiny, tiny little motor. They spin incredibly quickly, so we definitely need the gear train. The big issue with these is that these only run at 3 volts. If you run them at 5 volts, they overheat. If you run them at 7 volts, they melt plastic around them. I've attempted to use motors like this before. In actual fact, in one of my very first attempts at a drum spinning ant weight, I used a motor like this with a gear train to try and run the drum, and ended up melting the plastic around it. It was not a good time for anyone concerned. So we're going to avoid that, because at least for now I want to keep my flea weights at 2S, so we need to find a better way to do this. Now, one way would potentially be to mount a different motor in here, but that would be a lot of time and effort to get all of this stuff right. The other thing that we can do is, just like the 10mm motor that we had earlier, we can toss this to the side, and then we can talk about the servo. But to do this, I'm going to go more to a first-person view, because we're actually going to do a disassembly of the servo, because it's not everything in the servo that I want, it's only some things. So here we go. This is a 9-gram servo. In fact, this here is a 9-gram servo from Hobby King, and it cost me a couple of bucks, somewhere up to 7, I think. But kind of looking through that clear case, you can kind of see some of the components that are inside this thing. Now, normally there are stickers on the front and back. These are actually partially to help keep the thing together, because there is a bottom plate and a top plate here held together with 4 screws, and then there's a kind of middle grounding section, or middle housing section. And the stickers help to kind of keep everything aligned and keep it all stuck together, even when you remove the 4 screws. This one I've had apart once before, which is why some of the screws are already out and ready to go. But we're going to pull this apart together on camera, and I'm going to talk to you about some of the parts inside this servo. Part of the reason why I told you not to use them for ant weights, and then talk about what we're going to do to this to actually make it usable as a drive system in a flea weight. So let's get to cracking this thing open. The first thing obviously we need to do is remove these screws. Once we remove these screws, everything else kind of just falls apart essentially. Servos are, like I said, held together. They're just like 3 pieces of plastic. There's not a lot involved in getting a servo to come apart. The main issue is these screws, because they have tiny little screw heads in them, and they can be quite an issue, because they will sometimes strip out, which is not good, because then they won't move at all. So there we go, that's that one all the way out. Now, some of these won't actually come all the way out of the plastic entirely. They'll just sit in the plastic, and you're just going to have to deal with that. All right, I will get back to you when this is more apart. Hang on, almost there actually. I think I can probably just, so probably a couple more turns on both of these and we're good to go. But as I said, this thing is like falling apart in my hands. All right, give me a second here. Okay, so that is now our 4 screws out of there, and literally to get this thing apart, all we need to do is pull. So we pull the bottom plate off, which has got the 4 screws still holding in it, and then we can spin it around this way, and we can pull the top plate off. Now this one we have to be pretty careful with. So in under here, you see the reason, well, part of the reason why I say never to use a 9-gram servo as an ant weight drive, completely unmodified. Well, there's 2 kind of reasons. One, in here on this big tooth at the top, there is this little locker which stops it from rotating more than 180 degrees. You can knock this off and make some modifications and make this thing run at 180 degrees, more than 180 degrees, and turn it into a continuous rotation servo. There is a continuous rotation servo hack that you can definitely do with these. But look at this gear train. There is so many gears in here. If you compare that to a 50-to-1 N20, there is way more gears and way more gear ratio going on in a 9-gram servo than there is in a 50-to-1 N20. So these things are slow. Now, the other reason that I say don't use a 9-gram servo in an ant weight is if we actually pull this motor out of here, this one right in the bottom. So this is the gear train, as I said. So there's many parts to a servo. There's the gear train at the top. There is a motor controlling board, and then in under here, between, just right in there, this little black dot you can basically see at the top there, that is a potentiometer which tells the servo where it actually is positioned, or in actual fact, it tells this control board where it's positioned. Then the control board takes your demand position, works out where the potentiometer is, and then tells the motor to turn one way or the other, and faster or slower to get to the position that you want in a good amount of time. So that's all of the components of a servo motor, and as I said, one of those is this drive motor down here. So this is the drive motor, and if you have a look at this against an N20, you can see this is a 10mm drive motor. So this is a flea weight drive motor. This is the same type of motor that I am putting, or I've already put into a flea weight. See, look at this. They are exactly the same. The only difference is this guy here has a whole bunch of gearing on the top of it. I mean, this guy also had a whole bunch of gearing on the top of it, but right now I've pulled that off. So now we're left with a servo motor, or with a 10mm motor and a gear. So this is good. This is what we want to drive our flea weight around. Now, this idea, obviously the motors are exactly the same, but the idea to do this actually came from the robot that wiped the floor with us last time. They were using this motor out of this a servo, and then one of the servo gears, and then after that gear train, they went out to, I think, the final gear stage out of a quadcopter, one of the small ones that uses tiny little motors and tiny little plastic gears. And that's what they were using to drive everything round. So these motors we know are up to the task and know can do the job. The thing is now what we need is we need that output shaft. We need a better output solution than this guy over here with his little crosshead thing that is terrible and awful and woeful. And to fix that issue, this is my solution. This here is the drive shaft out of a $9 really cheap RC car that you can get at pretty much every toy store in the world. If you go into any toy store in the world, find the cheapest RC car that you can get your hands on that is actually RC and not infrared or anything like that. It will have one of the really, really cheap toy motors, which if you've ever pulled apart any cheap toy ever, you'll know the type of motors I'm talking about, because it's always that same motor. It's got one of those with a single gear that drives this as the back axle. Now what's interesting about this is you might just be able to make it out on camera. Down where my finger is, it's got some like knurling on the shaft which helps it grab hold of plastic better. So that is what we're going to use to mount our wheels onto. We're going to make a way to connect the servo motor to this outside gear. The problem that we've got right now is that this servo motor gear has tiny, tiny, tiny little teeth, and this gear has a lot bigger teeth. Thankfully for me, I am a collector of all sorts of tiny little parts, and so I went through my gears drawer and found this. Now this is a tiny little gear that has the correct output size, or correct shaft size for this motor, and also meshes really, really nicely in here with this big gear. It's kind of hard to show that meshing without actually attaching the gear to something, but just take my word for this one, it does mesh really nicely. Now I think, from memory, this gear came from one of those like random gear packs that you can find on AliExpress and any kind of cheap from China site. They'll always have just a bag full of gears that are designed for, you know, making robots and different bits and pieces with. So I got a couple of those bags ages ago, and I found, I think, 4 of these in amongst all of my stuff. So I would say there is 2 of these in each of those bags, but then again, you know, as with anything assorted bags from China, it's going to be a lucky dip. So we're going to, first of all, pull this gear off, the servo gear, and we're going to attach this bigger gear. Now let's hope this goes on. First try. Let me try the other side. Come on, get on there. Just got to try and do this without knocking the camera over. Alright, there we go. Finally managed to get that on. I did actually need to use the drill press just to drill that one out a little bit. It turns out that this one, this gear here, is not actually the same size as a gear that I was testing with a little while ago. So that was a little bit interesting. But drilling it out, I also added just a tiny blob of super glue to the end of the actual motor shaft before sticking this gear on, and everything seems to fit pretty well. So now it is time to do a bit of a test fit. So I have some 3D prints next to me, like this. So these are my test fit pieces. I also cut down that long motor shaft. So that long output shaft. So we've just got the gear, a little section to ride on, and then the actual section that we want to put the wheel on over this side. And yeah, so it should go together like this. Motor goes in here, and that gets a clamp over top of it to hold everything in place. Has a little bit of play left and right, but no play up and down. So when it clamps down, it just locks in place completely. And then this guy goes in here. Wait a second. Damn. Okay, so it seems like in the CAD model, I completely forgot that the gear actually needs to get past this mounting block. So the idea was that the shaft went in there, and then the clip goes over top and screws into place. However, the gear doesn't get past the mounting block. So I guess we're going to have to reprint that and try again, hey? Okay, so that is it all set up and ready to go. Now it is time to actually put some battery power onto this and see how we go. Now this is not going to be a full LiPo voltage. It's probably not even going to be a full 6 volts. I don't know how good these batteries are. I really just want to see how fast we are at the output, because obviously we've only got one gearing stage on this, and I think it's about 2 to 1. So this could be pretty nuts. Now, if it is pretty nuts, then I don't know what we're going to do, because I really don't have time to do any more design or work out another system that we can use. So we're just going to have to hope that this one, as it currently stands, is going to work out for us. So let's give it a bit of a quick shot. So first we'll connect one of these leads. I've done these with alligator clips. They should just clip on there nicely. And then the other one, we're just going to touch to the back here, and it should spin in one direction. Here we go. 3, 2, 1. And I'm getting nothing. I'm definitely getting something kind of jammed up there. That's not good. Here we go again. Let's try that a second time. 3, 2, 1. Oh, wow. Okay. That is loud and insanely fast. Obviously, we do not need all of that speed. That is quite an issue, actually. That's going to be too much speed for sure. It would make an interesting flea weight, but that is crazy quick. I mean, obviously we could install a smaller wheel on here, so even though it's going crazy quick on the output, it's actually not traveling too fast, I guess. But I don't know, that might be a little bit too quick. I'm going to have a bit of a mess around, see what I can do. The next thing you see might be me either making a chassis for both of these parts, or we'll come back here and have a bit of a chat about what I want to do moving forwards, because I am running out of time to make this video, and that did not go according to plan. That was way too quick. And like I said, we're probably running about 5 volts, I reckon, maybe 4.5, because these batteries are old and really do need to be charged, actually. And there you have it. It is, well, almost a flea weight. It's exceptionally quick. As I kind of mentioned when we did that first little spin-up test, this thing is just so fast, like crazy, crazy fast. It's good fun to drive, and if it had any traction at all, it would be way faster than what it is. At the moment, it's just using single tiny little O-rings for wheels, and that means that it was skidding and slipping and sliding all over the place on this table, which, yeah, was interesting. But like I said, it means if I gave it some like proper silicon wheels or something, this thing would just fly around the arena, and it would be a lot of fun to drive, actually. The big issue is that at the moment it is 60 grams, which leaves me 15 grams to get a weapon on and probably better wheels, and I don't think that's possible. So this one might be the ant weight that I the flea weight that I don't run a weapon on. So I'll either run it as a wedge, or I could potentially use it as a thwack bot as well. If I get some nice big grippy tires on it, this thing would throw itself over no problem at all. There is so much speed in this thing that would be a lot of fun. It would be a crazy flea weight to drive, but it would be a lot of fun. Also, I can probably take out some of the weight because the electronics that I'm using right now are the ant weight electronics that I've just pulled out of one of my lone bots. So that stuff can get replaced and shrunk down, which will save a lot of weight, I would say, moving forwards with all of this. But yeah, so there you go. I hope you guys have enjoyed this one with my little experiment into a crazy fast flea weight drive system. Yeah, and I will see you in the next video.